Okay, we're going to continue to find the zeros of this equation. So how do you find the zeros? You're going to do finding zeros means when the y is equal to 0. So literally all you do is you replace the y by 0 and you solve for the x. So let's just do that. So the equation was y is equal to 3 over x minus 2. And there was a 2 in the front and then plus 1. Okay, so you're going to replace the y by 0 and you're going to isolate for the x. Okay, first thing you need to get rid of is the plus and the minus stuff. And then you bring that on either side. That becomes 3 over 2x minus 2. Now, don't make your life complicated. You could multiply 2 with x and then 2 with minus 2, but you don't need to because you're going to cross multiply like this, but you're literally multiplying all the factors together. So you could just write minus 1 times 2 times x minus 2 equals 3. And now minus 1 times 2, that becomes minus 2 times x minus 2. Remember, your goal is to isolate the x, so you're going to be dividing now by the minus 2. What you do to one side, you do to the other. This cancels out. Now you're left with x minus 2 is equal to 3 over negative 2, which you can put as negative 1.5. X is equal to negative 1.5 plus 2. X is equal to 0.5. Now this is going to become important because your 0.5 is the marking or delineation point of what allows you to tell you if the graph is positive, when is the graph negative, and so on and so forth. So I'm just going to redraw this graph. I'll make a double screen so that we could see what the graph's going to look like next to it. So basically, you're going to have well, it should have been a solid line. Let's make it a solid line. So remember, if we remember what our graph looked like, we had the asymptote at 2, and then we had another one at 1. Okay, so remember our graph had this at 2 around like that. Okay, pretend it's straight. And we had one at 1. And then we had the fact that it was decreasing and something like that. And now we actually if I draw this properly with the 0, now that we know it's going to be at 0.5, your graph probably goes like that. Of course, you could always come up with other points. If you want precision, you just make up some other values. Like what happens if x is 0? Well, if x is 0, it would be 3. So y is equal to 3 over 2, 0 minus 2 plus 1, which is equal to 3 over 2 times negative 2 is negative 4 plus 1. That's negative 0.75 plus 1, that's 0.25. So I actually have a point at 0.25. So at 0, it's 0.25. It's probably around there. So this is how you plug in points. You just literally plug them into the x or the y position and solve. Okay, so that's basically how to find the zeros. At this point, you can say things like, oh, when is this positive? So the function is going to be positive every time it's above the x-axis. And you're going to use your 0 as a marking point. So in this case, you're going to say, well, you're always going to look at the x's, by the way, for positive and negative. So you're looking at the x's, x values. So we're going to say it's positive everywhere here. So all of this is positive, and all of this is positive, all the way up to here. So at first, we're going to say it's positive from negative infinity all the way to the 0.5, and we could include it, and of course not include that one. And it's going to be positive again from the, what do we call this here, after the vertical asymptote. It's going to be the 2, not including all the way to positive infinity. And now let's look at when the function is negative. So basically I'm looking at only these. It's never negative anywhere else. The negative, again, we're going to be looking at the x values. The negative is from here, which is this point, the 0.5. So we're going to say not including, or we could, sorry, you could say including, because you could always include those. Let me just erase this one quickly. Okay, so you include the 0.5 all the way to 2, because it stops right here. You cannot go past the 2, and you don't include the asymptote. So that's for when is it positive and when is it negative. Another word for this is called the sign. So this is called the sign. Okay. And the variation, when is this increasing or decreasing? Well, this is always going to be decreasing. So the variation is always decreasing. It doesn't happen that it sometimes increases and sometimes decreases. It always increases or decreases. Okay, so that's what it is for the standard function of the rational function, the standard version of the rational function. So finding the zeros is that we replace the x by 0. Finding intervals, you have to think about making a number line. Let's do an inequality, because sometimes inequalities pose problems as well.